Okay, in this video, I want to look through examples 3 and 4 a little bit more closely. Okay, so in example 4, which you hopefully already studied in the text, they were trying to find the probability of drawing 5 cards that are all spades. All right, and so we know that probability is the number of ways, I'm going to say of success, I'm going to use this over the number of possibilities. Okay, so the book counted up the number of possibilities as combinations. They said, how many different ways could you draw 5 cards? And so they said, the denominator would be the combination of 52 cards selected 5 at a time, right? And then they said, the number of ways you could succeed is if you looked at the 5 cards that were drawn, all right, there are 13 possible spades. So if we removed all of the other cards from the deck that weren't spades, there would be 13 cards left that are spades, and you would need to pick 5 of those. Okay, so they looked at the number of ways you could get a hand of spades, of all spades. So the numerator would be that combination. So if you write it out, you would have 13 factorial over, for combinations, we would take 5 factorial, and 13 minus 5 is 8 over 8 factorial. Okay, so that would be my combination of the numerator. My denominator, we could obviously just put these in the calculator to get the answers, be 52 factorial over 5 factorial times 47 factorial. So that would be the denominator. And the book has calculated out for us that this comes out to be, the number 1287 for the numerator over 2,598,960 for the denominator, which comes out to be about 0.0005. Okay, so the chance of getting all of one deck of cards, remember, we will often like to talk in percentages when we think of probability. So this would be, we move 2 decimal places, this would be 0.05% if we move 2 decimal places. So that's very, very unlikely that if you were given 5 cards, just off the top of the deck, that they would all be the same suit, all being spades, right? Now, when I've read the problem, I always try to figure it out before I look at the solution. I came up with I didn't think of it this way, all right? I thought of what are all of the possible ways that we could have 5 cards drawn, okay? Now, when they use these combinations, they were saying that order does not matter. Well, I was thinking about the order actually mattering. Okay, so I said that the probability would be the permutations for the spades being organized over the permutations for the whole deck with 5 cards being selected. Okay, I thought, well, the order does matter. Those are different ways of dealing things out. So when I thought of what would the sample space be, kind of going back to the last example of rolling dice. Okay, my sample space would include rolling a 3 and then a 4, and a 4, then a 3. They both give me a 7, but those are 2 different ways to get a 7. Okay, so those are different events in the sample space. They both total the 7 though. So if we look at the event of getting a 7, they're both part of that event. But I was looking at all of the individual things, all right? Now, when you look at that, I would need to write that is 13 factorial over 8 factorial divided by 52 factorial over 47 factorial. All right. Will that give me the same answer? And the answer is yes. All right. So thank goodness, because Mr. Owen couldn't have been wrong. So it would have been disheartening to you if he was. If you look back up at the previous way of doing it, the 5 factorial could cancel out. It's the same in both the numerator fraction and the denominator fraction. So it will divide out if we multiply by reciprocals, that would cancel. And so we end up with the same result either way. So it is the same probability whether you think about the permutations for that or the combinations. So if when you read the problem you were at all confused as to why they picked combinations over permutations, there's not really one reason to pick one over the other. So you could think of, they were thinking of all of the possible hands that would be a success over all of the possible hands that you could draw. And by a hand, I mean combinations of 5 cards. And I looked at all of the ways that you could have those 5 cards handed to you, including their order, over all of the ways that 5 cards could be delivered from the deck. And either one results in the same answer. If you have to work this out by hand, I would say that, you know, looking at permutations is probably a little bit faster than looking at the combinations, because there's just one less thing in the permutation calculation. Okay, so hopefully you look through example 4 as well, and they give you an example of drawing different kinds of balls out of a bag is a pretty common thing in probability problems. They love using different color marbles, but here we have tennis balls, 16 of which are good, 4 are bad. And you know, you pull 2 balls out of the bag to go play tennis. It'll be mighty unlucky to draw out 2 that are bad. But let's try to figure out how unlikely it would be to pull 2 out in a row that are bad. Okay, so in order to do that, you have to look at the probability of, so the event, let's call it E, would be draw 2 bad balls. All right, and the sample space, so let's just write out S. S is just draw 2 balls. So the number of ways that we could draw 2 bad balls, we have to consider that there are only 4. We could do it one of 2 ways. We could do it, if we're not worried about the order of the balls, we could take the combination of 4 balls taken 2 at a time. All right. So we would only be able to draw from the set of bad balls, the subset of bad balls, and we would look at all of the ways that we could draw 2 bad balls. All right, so that would be the number of for the number of ways we could make event E happen. Then we have to look at the number in the sample space. Okay, well, for that we have 20 balls to choose from, and we're going to pick 2 of them. So the combination of 20 taken 2 at a time would be all of the ways to draw 2 balls out of 20, and we don't worry about the order. Just like in the last problem, we could have worried about the order and used permutations instead of combinations. And if we were to do that, we'll get the same answer anyway. So you can see in the book, all they did was they took, to get the probability that E would happen, they simply took N of E over N of S. And so once again, they just counted up the number of ways we could draw 2 bad balls from a group of 4 bad balls, and the number of ways that we could draw 2 balls out of any number of balls. And they were able to then do the computation. So you would want to just, in your calculator, take the combination of 4, 2. That one you could probably do by hand pretty quickly. And then you could do the combination of 20, 2. Actually, if you're doing this by hand without a calculator, the combinations might be easier, because if we look at this, this would be 20 factorial over 2 factorial, 18 times 18 factorial. More things would cancel out. We could write that as 20 times 19 times 18 factorial, all over 2 times 1 times 18 factorial. And the 18s would cancel, and the 2 would leave you with the 10. So you could quickly see that that was 190. And the numerator would be even easier to compute. So without a calculator, this wouldn't be too hard of a problem to compute, but you could quickly put it into your calculator.